Okay, guys, one of the student he sent me a question. He was confused from that question, so we are going to discuss that question. So let us start with that question. Okay. Okay. So this was the question. A student sent me this question that he was unable to do it. He was not able to understand that what we have to do the vaporization thing. Okay. So let me explain it to you, my dear. Okay, so you should open the data booklet in front of you because I need the values for that because this is the previous question. So in that you need a data booklet. Okay, first of all, what you are supposed to do? The compound name that is zinc bromide. So that is ZnBr2. It's a solid thing. Okay. Now, first of all, you should make the formation of it. Zinc, that is a solid, and then you got bromine, Br2. It's a liquid. It's not the gas. It's a liquid. Okay. So this is the formation. So formation, you have to calculate. So delta H of formation, you have to calculate. You have to find out. Okay. Now the next question. Zinc solid. It would change into zinc gas. Okay, and Br2 liquid that would remain as it is. So this is the enthalpy change of atomization of the zinc and its value is given plus 131. So this is plus 131. Okay. Now zinc would change into zinc plus 2. Okay, gaseous form and plus Br2 liquid, it would remain as it is. So this is the sum of first and second ionization energies. So its value is given in the data booklet. So can you please tell me what are the first and second ionization energies of zinc? 908. First is 908. Second 1730. 1730. That's perfect. Okay. Now if you see one thing has changed into the gaseous sign. You should change, first of all, bromine is a liquid. If bromine is a gas, then you should directly change it into its atom. But it's a liquid, so first of all, you should change it in gaseous form. So this one would be zinc plus 2 gaseous form, and you change bromine Br2 in gaseous form. Okay, so this is the vaporization. So its value is plus 31. Now you should use its atomization. So zinc. So you should change it in atomization. So zinc plus 2 gaseous form and then 2 Br, that is gaseous form. So if you open up the data booklet, tell me the bond energy value of bromine and bromine. 193. So here we got one bromine atom. So 193 would be written as it is. Okay. And then the bromine that would change into bromide ion. So this is zinc plus 2 gaseous form and 2 Br, that is minus 1. So this is the first electron affinities value is given minus 325, but we got the two atoms up here, two atoms. So that is why we should multiply it with 2. Okay, the compound to gaseous ions, that is the lattice energy. The lattice energy is minus 2878. Okay, so this cycle, my dear, that is going to start from here. So this is the starting point and the end point, that is this one. So this is the end point. So from start to end, we got this root. So this is delta H of formation. We have to calculate it, then put the values plus 131, then plus 908 plus 1730, and then plus 31, and then plus 193, and then 2 times minus 325, and then plus minus 2878. So write this thing up here. So if you calculate it, my dear, you will get the answer. Minus 385. निकला है आपका? That's wonderful. I'm going to give you a question, so you people are supposed to do it. Okay? Okay, do this question please. So you are supposed to find out the lattice energy. Hurry up. Draw the cycle and just draw it. Giving you 4 minutes for it. Hurry up. I'm going to do that question for you. So everyone should look at it and open up your data booklet in front of you. So please, everybody, just emphasize up here. So first of all, my dear students, you should write the compound up here. The compound that is CaCl2. This is the solid thing. Okay. Now, first of all, you should make the formation. In the formation, you should write down the element. Calcium is solid. So we got the calcium and we got chlorine, chlorine 2. So this is Cl2, chlorine is a gas. So this is the balanced equation, okay? So this is the formation value is given up here. This is minus 796. This is the formation things. Now you got the two elements, calcium and chlorine. So you should change them into gaseous sign. First of all, what should we do? We should change this calcium into calcium solid into calcium gas and write Cl2 gas as it is. Okay, so calcium solid change into calcium gas. This is the atomization, and atomization of the calcium is written up here in the question plus 178. Okay, now change the calcium into calcium ion. Calcium got the plus 2 charge. So plus 2 gaseous form and write Cl2 as it is. Okay, so calcium to calcium plus 2, that is the sum of first and second ionization energy. So if you open the data booklet, find out the first and second ionization energy.
Sir, plus 590 and plus 1150.
Plus 590 plus 1150. It is written on the data booklet. Okay. Now the next question, my dear students, this thing has changed into the gaseous sign. Okay. Now what should you do? You should change the chlorine into the gaseous sign. So first of all, we should do the atomization. So calcium plus 2 gaseous form, write as it is and write this 2 chlorine gaseous atom. So this is the atomization. So if you look in the data booklet, we got Cl bond energy, which is 242. Okay, so we got the 1 Cl2 up here, so multiply it with 1, so it would become plus 242. Okay, and then chlorine got the negative 1 charge, so change it in calcium plus 2 gaseous form, and then you got 2Cl, that is negative gaseous form. Okay, so this is the first electron affinity. A first electron affinity is written up here minus 349, but we got the two atoms up here, so we should multiply it with 2. Okay, now these this one would form this gaseous sign. Sorry, this is wrong. This one would form this. This is the lattice energy. So this cycle is going to start from here. This is the starting point, and this is the end point. From start to end, we got this energy, which is minus 796. The other cycle is all this one. Okay, so we should write down the values up here. That is plus 178, then plus 590, plus 1150, plus 242, and then 2 times minus 349, and plus lattice energy. Okay, so now you should solve all this one from here. Okay, and take it on the other side and let me know what the answer you got.
Sir, minus 2258.
Minus 2 to
58.
बिल्कुल ठीक है जी, minus 2258. So that is the lattice energy. Okay, so this is your answer. So everyone got it, how to do it? Because chlorine got only negative charge, not negative 2. If it got the negative 2 charge, then it would be the second electron affinity as well. Okay, so just take a screenshot of that question as well so that you can practice it at home. Okay, guys, now do this question. Minus
775.
minus 775.
77. 775.
Okay, let me check it. So Mg3N2, okay, ji? So first of all, you should make the formation of it. So this is magnesium, it's a solid, and then you got the nitrogen. Nitrogen exists in N2 form, gaseous form. Okay, now you should balance it. You got 3 mg, so you should put 3 up here, and nitrogen they are N2, so this is okay. So the formation of this one is given up here, that is minus 461. Okay, now you should change magnesium into magnesium gas. So 3 magnesium gaseous form and write N2 as it is. Okay, so this is the atomization of magnesium from solid to gas. So atomization of magnesium is written up here, that is plus 148. But if you look up here, you got 3 magnesium, so you should multiply it with 3. Okay, now the next thing, my dear, you should change this mg got plus 2 charge. So change this one into 3 mg plus 2 gaseous form and write N2 as it is. So this is the sum of first and second ionization energy. So what are these?
36.
736 and plus 1450.
Yes.
Okay, but we got 3 magnesium atom up here, so we should multiply it with 3. Okay, and then nitrogen would change into nitrogen atom. So you should write 3 mg gaseous plus 2 gaseous form and write 2n. So from the data booklet you see n triple bond n because nitrogen exists in n triple bond n. So it's 944. 44?
Yes.
Okay. So here we got 1 and 2. So you should multiply it with 1. So it would become plus 944. Okay. Now if you look, nitrogen to nitrogen minus 3. So total electron affinities he has given. Okay, so this one will go up. Okay, so this one is 3 mg plus 2 plus, this is not working up here, so I'm going to write this thing up here. Okay, 3 mg plus 2 gaseous form and 2n minus 3. Here we got plus 2148. 2148. This one should be multiplied with 2 because you got 2 atoms. So this gaseous sign would change into this one. So this is the lattice energy you have to calculate. So this cycle is going to start from here. This is the starting point and this is the end point. This is the start point and this is the end point. From start to end you got minus 461, that is equal to 3 times plus 148 plus 3 times 736 plus 1450 plus 944 plus 2 times plus 2148 and plus lattice energy. Okay, so if you calculate it, my dear, you will get the answer. Okay,
12703.
12703. हाँ यही है plus 12703. So plus 12703. So that is the lattice energy.